Hello, everybody. Bobby Francis here for Full Tilt Weather. We're going to go ahead and talk about Sunday's severe weather event over Iowa into parts of Texas. I guess we're going to start on the Texas side here because that's the one I have up. So, moving across into going to be probably more Monday night. Uh, this line looks to more be Monday night, some Sunday, some Monday. Stronger line of storms moving across Texas here. And we're going to go up into the Iowa, Nebraska, Missouri, Kansas, Oklahoma, Arkansas, Texas Panhandle are our primary areas we're worried about currently. We're going to nudge it forward. Storms firing either late Sunday night or early Monday morning. Most of this will more than likely be nocturnal. We're going to go through the northern side for. Oh, I have everything set to stem reflectivity, don't I? Okay, that can be fixed really quickly. So this is our severe parameters. We call these STPs. These are parameter markers for possible severe weather. And as you can tell, moves along the line, goes later up into parts of Minnesota. Your low in this depiction is going to be setting right about here, about Pinkerton, South Dakota, throwing southwesternly down along the line. As you can see the bars moving here, we're moving southwesternly around, over, and back down because it's cycling its own southwesternly. We're going to take a run from, let's try Iowa first. We're going to take a couple from Kansas and a couple from Texas too. This has been a really, really strong trend. So right here, this is your left bunker. This is your southwesterly, 55 knots. That's going to be about 62 mile per hour inflow occurring along the line. So you have a strong southwesterly jet between 61 63 mile per hour. This is our CAPE number, convective available potential energy, or instability is another word you could use for that. This is 552 is extremely low. Large tornadoes happen in 2200 to 2700 megajoule CAPE. Not much happens in 525. Like, this is extremely low. So instability here is definitely an issue. Level of free convection is separating. That is giving us what's referred to as a buoyancy issue. So there's a warmer layer of air laying below the lower side of formation. So you have your equilibrium up here and you have your level of free convection. So you do have CAPE moving out along the dew point and the warmer temperature. The blue line is your warm aerobatic air. So you're getting warm aerobatic air bringing stronger CAPE into the line. These CAPE numbers more than likely on the runs will trend upwardly. For this to become a severe scenario, we need to get up around 1100 to 1600 more than likely. This is going to be a real no-go at 225 SB CAPE. Not much of a threat there. This is what's called a hodograph. This is air moving within a cell. This is called a SCU-T. This is a standard SCU-T chart that's taken off of any weather balloon with a bunch of other stuff added to it. But these are your base numbers you're going to take off a weather balloon, your SCU-T chart. Your photograph here is going to tell you bending air. So we have a horizontal movement of air occurring between the 5,500 and 2,100 foot sectors. That's leading to, this usually is an effect you're going to see with hail. This bending line, this is air returning down into the line. This is your 55 mile an hour southwesterly inflow. It's kind of like this. You can't just take a top and be like, oh, well, I'm going to spin it. There has to be a force that spins the top, right? Well, southwesterly is severe weather's tornado top. That's what this returning line is showing right here, that we're getting strong southwesterly into the line. But will they fire is a really strong question. And down here you're seeing the differential occurring towards the line here of a lot of strong air moving under the cells. So you're seeing a situation where cells could not fire due to CAPE because there's not enough instability. A second scenario is the buoyancy doesn't allow it to get above 21,000 feet. Third scenario that it dies could be that the shearing within the first 1,500 feet just tears them apart. Because if you have too much turbulent wind, you have a cell that tries to form, or we refer to them as towers going up. Then you start to see holes get pushed through these cells. Well, what happens whenever you lose your vacuum of anything? Well, it dissipates. So these are all three possibilities. This line could not do a lot. But it's definitely got the southwesterly part going. And this is a part that we always look at for tornadoes. This run's thinking weaker tornadoes. That's probably adjacent to the SCAR program for the convective available potential energy, more than likely. Okay, so we're going to take one from Kansas. This is going to be the whole line. There's an issue of initiation, an issue of it being too close to the line. This is relatively the same run we just looked at. We have the equilibrium issue, 57. That's equating to about 64 mile an hour southwesterly. Usually you get above 60, it's a little too much. A lot of people don't realize you can have too much of a good thing. So, like, cells get to a point to where they can't evolve properly if one parameter is a little too high or a little too low. We still have the CAPE issue here, 662 megajoule. We still have the shearing issue. We still have the buoyancy issue, showing a strong rain curtain happening up around 23,000 feet. We still have the strong air returning, relatively the same run, just more southwesterly, and you're moving down and away from the low, which at that point is predicted to be over southeast South Dakota. So the further you move away from the low, the faster winds are going to shear down the line. So, you know, a stronger southwesterly is expected down along the line. Now let's move over to Texas. Or I guess we'll take one from Oklahoma. I don't expect a huge differential here. Could there be some tornadoes? Yes, if we get better CAPE. Current numbers, definite issues. Okay, this cell 61, we're getting about 64 to 66 mile per hour southwesterly right here. CAPE's still an issue. Buoyancy's still an issue. The CAPE is having issues on numerous levels. There's a second equilibrium top. returning southwesternly is not properly in place. This is more of a complete failed formation. See all these little graphs that we use here, and I post on the page constantly on Facebook or Twitter, wherever you follow us. These are just more of an easier digestion. The actual meteorology numbers we use through the SCUT, the SCARS system, the hodograph. Couple little pockets here. This is going to be pretty close to Odessa area. We'll take just a quick run at this. Oh yeah. Cape definitely does increase. Buoyancy issue dissipates. Wind along the line dissipates. Southwesternly's too far away from the low in South Dakota at that point. 60, 70 mile an hour winds do remain a threat. Overall, this is really what we're looking at, more of a 60, 70 mile an hour threat. This is something for the next event for tropical depression that's coming over Mexico that I guess I'll do another video on. This kind of looks like it probably won't happen. But we will see, Sunday night into Monday if we can get some formation. Stronger cells could be capable. Tornadoes could be capable. This is not the world's largest risk by any means. But there could be a couple of cells that are really destructive. Somewhere primarily right in here. Kansas, Nebraska, southern Minnesota, Iowa, maybe even into Missouri or Arkansas. Some models have shown it going that far, but we will see. So that's pretty much what we're looking at Sunday night into Monday morning. Thank you all for watching. I'm going to go ahead and get out of here. Y'all have a blessed day.